For centuries, humanity knew only 8 planets. They were different from one another, but they still seemed to follow an understandable pattern. Small, rocky worlds form close to the sun. Large gas giants develop farther away, where temperatures were lower and lighter materials could gather. Planets moved in stable orbits. Stars provided their heat, and when those stars died, nearby worlds were expected to die with them. Then astronomers began discovering planets around other stars. What they found did not resemble a larger version of our solar system. They found gas giants almost touching their stars, planets orbiting dead stellar remains, worlds lighter than cotton candy, and giant planetary cores stripped almost completely bare. Some exist in locations where formation models said they should be rare. Others appear to have survived events that should have destroyed them. A few are being torn apart before our telescopes, forcing scientists to watch planetary death in real time. These worlds are not violating the laws of nature. They are exposing how incomplete our understanding of those laws remains. The universe has built planets that seem impossible, and each one forces us to reconsider what a planet can be. The planet that survived its star's death. About 530 light-years from Earth is a gas giant known as 8 Ursae Minoris b, or Hala. Hala is larger than Jupiter and completes an orbit around its star in only about 93 days. That alone is not especially unusual. Astronomers have found many enormous planets moving extremely close to their stars. The problem is the star itself. Hala's parent star is a red giant in an advanced stage of its evolution. When a sun-like star begins running out of fuel, its outer layers expand dramatically. Any planet orbiting too close can be engulfed, heated, and destroyed. Measurements suggest Hala's star should previously have expanded beyond the planet's present orbit. The star should have swallowed Hala, yet the planet is still there, moving in a stable and nearly circular path. Scientists have proposed 2 extraordinary explanations. The first is that the star was once part of a binary system. 2 stars may have merged before either expanded far enough to destroy the planet. Hala somehow survived the violent collision and remained in orbit around the combined star. The second possibility is even stranger. Hala may be a new planet. It could have formed from material released during the stellar merger, meaning it was born from the remains of 2 dying stars. Either explanation changes the story of planetary survival. Hala may be a world that escaped destruction or one created by the disaster that should have killed it. Planets orbiting an undead star. The first confirmed exoplanets did not orbit a normal star like the Sun. They were found circling PSR B 1257 plus 12, a pulsar located 2,300 light-years from Earth. A pulsar is the dense, rapidly rotating core left behind after a massive star explodes as a supernova. It can contain more mass than the Sun compressed into a sphere only about the size of a city. Beams of radiation sweep through space as it spins, producing pulses so precise they can behave like cosmic clocks. This is not an environment where planets were expected. The supernova that created the pulsar should have devastated the original planetary system. Its explosion would have blasted material into space, while the sudden change in stellar mass could have thrown surviving planets out of orbit. And yet, planets are there. They were detected because their gravity caused tiny changes in the timing of their pulsars' radio signals. Their existence was revealed through slight interruptions in what otherwise appeared to be a nearly perfect rhythm. Scientists are still uncertain about how these worlds formed. There may be rare survivors of the original system, although enduring the supernova would have been extremely difficult. A more likely possibility is that they formed afterward, assembling from a disk of debris left by the exploded star or material captured from a companion. These planets, therefore, may be second-generation worlds, planets born after the death of the star they orbit. Their skies would be unlike anything on Earth. There would be no warm yellow sunlight. Instead, the pulsar would flood the system with intense radiation and high-energy particles. These are real planets orbiting the remains of a dead star. Worlds built where a planetary system should have ended. The planets with the density of cotton candy. The Kepler-51 system contains some of the strangest planets ever measured. Several of its worlds are nearly the size of Jupiter, yet they contain only a small fraction of Jupiter's mass. Their average densities are extraordinarily low, more comparable to styrofoam or cotton candy than rock. Water, or the familiar giant planets in our solar system. Astronomers call them superpuffs. A superpuff is not made from fluffy solid material. It likely has a relatively small core surrounded by an enormous atmosphere of hydrogen and helium. That atmosphere extends far into space, making the planet appear much larger than its mass would suggest. But these swollen worlds create a problem. A weakly bound atmosphere should be vulnerable to radiation from the parent star. Over time, stellar energy ought to strip gas away, shrinking the planet. Yet some superpuffs have maintained their enormous sizes. When Hubble examined planets in the Kepler-51 system, it encountered another obstacle. Thick atmospheric haze or clouds prevented the telescope from seeing clearly into their lower atmospheres. These planets are not only unusually large in light, they are concealed. Scientists believe their youth may partly explain their condition. They formed relatively recently in cosmic terms, and may still be hot and inflated. As they age, some could cool, contract, and lose parts of their atmospheres. But Kepler-51d may remain an extremely low-density oddity for much longer. If a human could somehow descend into such a world, there would be no surface waiting below. The atmosphere would gradually become denser and hotter, surrounding the traveler in an increasingly crushing ocean of gas. Our planet can therefore be almost as wide as Jupiter while processing only a few Earth masses. The universe found a way to make a giant world that is barely holding itself together. The naked core of a destroyed giant. TOI 849b occupies a region where scientists expected to find very few planets. It moves extremely low to its star, completing an orbit in less than one Earth day. Radiation in this region is intense enough to strip atmospheres from Neptune-sized worlds, creating what astronomers call the hot Neptune desert. Yet TOI 849b is there. It is approximately 3 times wider than Earth, but around 40 times more massive. That combination makes it far denser than a normal Neptune-like planet. Scientists believe it may be the exposed core of a former gas giant. Perhaps it once resembled Jupiter or Neptune, surrounded by a massive atmosphere. Then something removed almost all that gas. Its star may have blasted the atmosphere away. Violent collisions could have stripped the outer layers, or the planet may have begun forming as a gas giant but failed to gather an atmosphere before the surrounding disk appeared. Whatever happened, the result is a planetary interior left almost completely exposed. In our solar system, Jupiter's core is hidden beneath thousands of kilometers of thick atmosphere and compressed fluid. We cannot see it directly. TOI 849b may offer astronomers a view of what remains when a giant planet loses its disguise. It is not simply an unusual world, it may be the corpse of a much larger one. The planet hotter than most stars, Kelt 9b, is a gas giant orbiting an extremely hot blue star. The planet circles so close that 1 year lasts less than 2 Earth days. Its dayside temperature rises beyond 4,000 degrees Celsius. Familiar chemistry begins to fail. Molecules that might normally exist in a planetary atmosphere are torn apart by the heat. Hydrogen molecules break into individual atoms on the day side. Winds carry some of that material toward the cooler night side, where atoms may combine again. The atmosphere is caught in a continuous cycle of destruction and reconstruction. The star also bombards the planet with intense ultraviolet radiation, causing its atmosphere to escape into space. Kelt 9b is being slowly eroded by the object it orbits. The existence challenged earlier expectations because giant planets are thought to form much farther from their stars, where temperature allows large amounts of gas to collect. Kelt 9b could not have formed in its present location in any simple way. It must have migrated inward after its birth or been thrown into its extreme orbit through gravitational interactions. Now it moves around its star at a distance where no planet should remain comfortable or stable forever. It is a gas giant living inside an environment more like the outer atmosphere of a star than a normal planetary system. The world being eaten alive. WASP 12b is another hot Jupiter, but its destruction has progressed even further. The planet orbits only a few million kilometers from its star and completes a year in roughly 1 Earth day. At that distance, the star's gravity pulls much more strongly on the planet's near side than on its far side. The tidal force has stretched WASP 12b into an egg-like shape. The planet is so close that its upper atmosphere has expanded beyond the region where its own gravity can hold it securely. Material is being pulled away, creating a stream of gas that feeds the star. The star is eating its planet. WASP 12b is also one of the darkest known exoplanets. Instead of reflecting much visible light, its atmosphere absorbs much of the radiation falling upon it. From a distance, it would appear almost black against the glow of its star. The planets exist in a temporary state. It cannot remain so close forever. Its orbit is decaying, and over astronomical time, it may spiral into the star or be completely torn apart. Astronomers are therefore observing a world during the final phase of its life. Most planets we discover appear stable because human observations cover only a tiny fraction of their existence. WASP 12b is different. Its destruction is happening quickly enough by cosmic standards for scientists to detect the changes. It is a planet we found just in time to watch it die. Why these worlds matter. None of these planets truly violates physics. Hala did not magically survive the impossible. Its history is simply more complicated than the earliest models predicted. Pulsar planets may have formed from the remains of destroyed stars. Superpuffs can exist beyond young, low-mass planets, sometimes retain enormous atmospheres. Exposed cores reveal how radiation and collisions transform planets. Hot Jupiters show that worlds can migrate far from their birthplaces. The phrase "should not exist" really means that our first explanations were too simple. Before the discovery of exoplanets, planetary science was built mainly around one example: our solar system. Rocky worlds remained near the sun. Giant planets stayed farther away. Orbits were mostly orderly and nearly circular. We assumed other systems would look similar. They do not. Planets migrate. Stars merge. Atmospheres escape. Gravitational encounters throw worlds inward or outward. Some planets survive stellar death, while others are destroyed during the ordinary life of their stars. The universe does not build planetary systems according to one design. It experiments. The mysterious world that should not exist are warnings against believing that our solar system represents what is normal. Hala circles a star that should have swallowed it. Planets orbit the radioactive corpse of an exploded sun. The Kepler-51 system contains giant worlds with densities similar to cotton candy. TOI 849b may be the exposed core of a destroyed gas giant. Kelt 9b is hot enough to tear molecules apart, while WASP 12b is being consumed by its own star. Each world tells a different story. One survived destruction. One was born after destruction. One is barely dense enough to resemble a planet. Another has been stripped to its interior, and some are being erased while we watch. These planets do not prove that nature has broken its rules. They prove that humanity had not discovered all the rules yet. Our solar system gave us the first chapter of planetary science. Exoplanets reveal that it was not the entire book. Beyond the sun are worlds formed in violence, living beside dead stars, losing their atmospheres and surviving events no planet was expected to endure. They should not exist according to the simplest versions of our theories, but they do. And somewhere beyond the reach of our current telescopes, the universe may already have created something even stranger.